Okay. So thanks very much for joining me in this afternoon session. I realize it's always a toss-up towards the end of the day how early you want to start drinking beer or something like that. So thanks very much for sticking around. My name is Mike Bishop. I'm the Chief Systems Architect for Prescient, and I'm also the Managing Director for a platform that we'll be talking about a little bit today as kind of a, forgive the abuse of the term, but a use case, a vignette of how we as a business opted to go with some of the technology we've invested in, built upon, to bring a new capability to market. And given that this is in the business track, we're deliberately keeping it at I'll say a pseudo non-technical level. And I really just want to emphasize that we're talking about tools in a generic sense. Obviously, Hadoop is a powerful tool. We selected it to do things that there's some cross-pollination across other tools that we use in our toolbox, and we'll show you some pictures of those in a bit. But if we could go ahead and pull the slide up, please. It's all right, no need to panic, no worries. Almost. And there we go. So I'll bounce back and forth between the problem we're trying to solve as a company and the business decisions that led us to build what we did build. And I'll begin that process with just a little bit of background on who we are as a company, because a couple years ago, we were definitely not a technology company. My background at prior military, but computer science, mathematics, I've always been involved in technology for the last 20 plus years. But as a company, Prescient was a defense contractor. We have a lot of contracts within the United States government where we provide primarily support to our old brethren, those who we worked with when we were active duty in the military, but especially the intelligence community as a whole. And so one of the contracts we have is within the Defense Intelligence Agency for their traveler safety and insider threat. And obviously, from the description in this presentation and what you see on the slide, that's still what we're talking about, but the way the government consumes it is highly analog. I know that comes as a surprise to most people that are familiar with government operations, but it's a slow process where they pull together information, they try to provide a brief that's usually outdated before someone goes to some place where they might get hurt. And as the events of yesterday in Turkey and a few weeks ago in Orlando, in Brussels and in Paris, this is obviously a topic it sucks that we live in a world where we have to have systems that help us identify where threats exist and where they may manifest against us. But the point is that even though we've had a contract and we've done this for years and years in one space, supporting one type of customer, which was in the public sector, we realized a couple years ago that there was really no one using current technology to provide it on scale to private individuals, to companies, to the private sector as a whole, to corporations and leisure travelers. And so the first thing we did is those 4 bullets that we provide, we recognize that we need to systematize the manner in which we collect that information so that we can identify kind of the threatscape. What does an area look like? What problems exist in a given part of town that you should avoid based on who you are? Recognizing that threats, every one of us has a different risk profile. It's significantly more dangerous to be a female nearly anywhere on the planet, but it's way more dangerous to be a female in certain parts of the planet. And so looking at what we call cultural parity assessments, recognizing that we have to take into account culture as much as we do just the physical threats that present themselves or environmental threats or health threats. And those 3 topics, by the way, inform the basis for a very robust ontology that we'll talk a little bit about. So these 4 bullet points is really what we provide in terms of real-time threat awareness, literally while you walk down the street, getting a heads up that you're going into an area of town where statistically bad things happen. I'll show you some examples of that in a minute. And all of this over the course of the next few slides, in the next 25, 30 minutes or so, we'll talk about how we use some of the technology. But really the focus is how you pick the tools you need for your business to succeed. So as with anything that's going to be a reliable service, these 3 taglines here as far as flexibility and scalability, high availability, those are standard. Everyone that has anything that's mission critical has to contend with that. But I want to focus on the flexible models and processes. I want to talk a little bit about how when you're trying to understand what's happening in an environment, you don't always know what you don't know. You can be pretty sure that you don't have full context. But you can collect enough information to build a baseline to say this is generally a safe place, this is probably an area to be avoided. But then there's this whole slew of things that you can't possibly know. For instance, when you have a lone actor who's going to go in as a shooter in the club in Orlando, you can't predict that without getting way deep, farther than we're ever going to go as a business, and nor that I should ever encourage anyone to. The point is that you're going to have lone actors, you're going to have people that are outside the bounds of what you can collect information on. But what you can do, and we'll show you, is you can build statistical models that inform, call it a heat map for just a general case. These are areas where a pattern is consistent, and you can apprise people of that as they move around and provide that alerting. And from a business standpoint, you've got to balance the human and the technology. I've got another slide, I think, in 2 or 3 that talks about where, as a company, every one of us has to make a decision about where the technology is going to be a force multiplier, going to allow individuals to work more efficiently, and where, in other cases, it's just going to become an impediment. I'm a firm believer, even though I've built a career in technology, that many problems can be solved a lot better than most people will accept with just a pencil and paper, if you'll just think hard enough about it, and then develop a process. But when you do need to scale, and you need to cover millions of people moving around tens of thousands of locations, there's obviously no way to do that manually. And so balancing the technology with the right team, the human, is an incredible challenge, because you obviously invest in both of those areas. So before we get into any of the more technical discussion, again, keeping it at a fairly high level, I want to show you what the tools look like so you have some more context. I took these screenshots literally in the airport while I was sitting there having dinner in New York City last night. I was at MongoDB World for the first half of that, and now I'm here. And I saw on the news that, as many of you did, that airport in Turkey had been under attack. And so I opened up our dashboard, and you can see some shaded regions over in this region here. I don't know if I can, yeah. This is where, statistically, we have a lot of data that says there's bad things that happen there, or maybe you should be cautious if you go to those areas. Here, where we have a circle, and I didn't draw this circle, by the way. This was on the dashboard, what we call the Prescient Traveler dashboard. And this was a very early report. You can see we only had 10 deaths coming in. And so we just kind of put a halo around that area. And you can see that on my mobile phone, which I took a screenshot of and just superimposed over top of the desktop map, you can see that 8,100 kilometers away from my current location, these things were happening. So that was within minutes of it occurring. And in many cases, for instance, with some of the things that have been happening in Paris, we've been able to get even a couple hours ahead of any news coverage. And where we're monitoring social media and corroborating that with other sources is really where the kind of the art is in this data science of teasing out of all of the information that's floating around the world, what's relevant to people where they stand. And that's kind of the mantra that we have is twofold, is how do you make the information you provide to people relevant? Because anyone who's traveled internationally, especially if you've done it with a big company, they probably have some sort of traveler safety policy. They have a brief for you, or they at least tell you if you're going someplace kind of dangerous, be aware. That stuff, again, we produce that for our government clients, and it's antiquated. At best, it's 3, maybe 6 months old. It's usually more verbose than anyone's going to even read through. It's, unless you're really a security-minded person, it's just kind of an abstraction. And so we wanted to focus on making the information relevant. And in a minute, you'll see that there's a huge amount of information. I'll jump to one of the punchlines. We've got over 48,000 sources of information that we're pulling on to build these threat maps that you see, and to provide these narratives, these very concise narratives on what's happening around you. But again, we had to make it resonate with the individual. So I use the term sparingly because it gets abused, just like use case, but big data. If there's anything you can do of value in terms of reporting threats to individuals that relates to big data, it is the ability to correlate threats to individual attributes of a person or an entity, recognizing again that a female has a higher risk profile in most areas of the world, but also recognizing that people are profiled. If a pickpocketer in Naples, Italy, which by the way, Naples is statistically the pickpocketing capital of the world, they're looking for someone who looks like a good mark. Someone who looks like they're probably fairly affluent, probably carrying some cash in their wallet. You're being targeted all the time. And I'm not a fearmonger. I'm not trying to say, hey, don't go to Naples. What we're trying to do is be an enabler. Go to Naples. Just be very cautious in this area of the market. Maybe you want to stay to the east side because we know these things happen there. But how do we get that level of insight down to a street level? Because if we zoom into this map, and I'll show you some of these in a minute, it's down to literally a street level. And yes, there is some subjectivity in that, where these boundaries are drawn. But again, how do you make that relevant to an individual based on demographics? To whatever extent one of our subscribers is willing to say, I'm this ethnicity, this nationality, this skin tone, this gender, this sexual orientation. All of these things affect your risk profile, and that's just a fact. There's 8 countries in the world where, while I certainly pass no judgment on anybody in terms of gender assignment or anything, we've been very open in this conference about that, there are 8 countries in the world where it's punishable by death. And so you should be aware that any public display of that kind of behavior is going to be it's going to attract attention. And if I hearken back to the experience, I mentioned kind of our pedigree as a company and where we come from. Any of you guys ever seen the movie or the television show The A-Team? Anyone? Okay, I knew at least a few of you had. So A-Team is an abbreviated form of SFODA, or Special Forces Operational Detachment Alpha. These guys go to places where they definitely would stand out normally, but for 6 to 12 months, they try to build rapport with locals. And that starts with understanding the culture. It starts with not offending people. It starts with not alienating them. And frankly, we as Americans, not everyone in this room is obviously American, but we have a reputation of being very insensitive to people around the world. And that's not a great way to start anything. It's a very good way to also make yourself a target. So again, I use that ethnicity and I use the nationality as just a few attributes that can say that statistically you're more likely to be targeted or at least recognized in this area. And so when we think about it from that perspective from an intelligence operative's perspective, we want to keep a low profile. And so for both business continuity, not upsetting people whether you're at a dinner table, which we have a lot of cultural norms and taboos pictographically represented in the app. That's another facet of what we do, is we just want to lower that profile. So again, big data allows us to do that, to correlate what I call a threat vector or threat parameterization. We decompose threat vectors into the individual attributes that they exploit in a person. But here in the mobile app, you can see I'm getting some situational awareness. And now this is a screenshot I took shortly after the Orlando shooting. And I'm not suggesting that we're in a phase yet where we're in a predictive mode, but we're moving in that direction. And you'll see in the next slide or two where we're at in this timeline of progressing in terms of data science processing and harvesting the vast amount of information that's out there and really kind of distilling meaning from all the noise. But what you see on the right here of this block, this is actually where the shooting occurred. This, of course you're not seeing my pointer. So this is where the shooting occurred, and this is a persistent elevated threat region in Orlando. So as you see, I'm getting proximity alerts and the other pop-up that tells me my distance from that. So by correlating a user's location to where there's persistent threats, we can send out notifications to let you know that if I have in my application, for instance, 500 meters, I'm just walking around town, I'm unfamiliar with the city, I'm just looking for a place to get dinner tonight, but it's new to me. And I get a note that says, you're 500 meters away from an elevated threat region, maybe you want to take a right, not a left. So that's actionable information, actionable intelligence, you might say. But in this case, we didn't have a red area exactly where the shooting occurred. Okay, there wasn't a statistical argument to make for it. We had a lot of data that suggested, though, a block and a half away, though, there is an elevated threat. So again, we wanted to provide users the ability to say, what's relevant to me? Because that's another complaint we've seen, and I've personally dealt with when I used to have teams of people we would deploy around the world on very short notice, is that the information they get to read before they go into some place is not at all tailored to them, and it's outdated. We wanted to solve that problem. So I've talked a lot about the data. I haven't gone into great depth in it, but I've talked about the kinds of information we get. Obviously, most of it's unstructured, so how do we get meaning out of that? And that's where the automation comes in, and so we can do that on scale. This is our Threat Watch Center in Chicago. We've got DR sites in a few other areas around the country. The shaded regions, by the way, are segments of the national power grid. So like any mission-critical system, you have data centers, you have all kinds of redundancy for power and failover. We have that in a few locations because a lot of our back-end analytics, which we'll talk about in just a moment, We're using SAP HANA for the real-time sentiment analysis and entity extraction. We're doing more and more of that in Hadoop as time goes on, but I'll jump to another punchline here. Hadoop for us right now is our data lake. We have roughly 5 petabytes of on-site capacity with the compression that we get on our particular data set. And so the entire purpose of that system is to curate information, because human analysts can't look at everything. If we've got 48,000 sources and that grows on a daily basis, we can't possibly hire a staff large enough to monitor that. And so back to the very first point I made on the slide, balancing technology with human. How can we empower our human analysts who have very unique skills? And over time, we are beginning to automate things that they do. When they make a decision that says, here's the criteria for an elevated threat region, a machine learning algorithm can be developed that begins to interpolate data and say, well, if this is this, we have property values and demographics, but no crime statistics. What we do right now is an overhead imagery analysis. There are ways with the geospatial clustering algorithms in HANA to do that in an automated level, and we're playing with that. But again, this is just one tool set, and right now HANA is central to our processing, and from a business standpoint, early on, I recognize that we're not going to be able to afford to scale in that area unless we just have, obviously surplus of cash inflow, which is a great problem to have as a business, but we're not there yet. Over time, we're going to be moving a lot of these more complex analytic processes that are reserved for HANA into Hadoop, and which is the main argument for Hadoop is, one, the scalability, and I saw that it was an entire ecosystem and a community that would allow us to begin piecemealing and kind of rolling our own, so to say, for these natural language processing algorithms that help us identify meaning in this ocean of data. And I know that I keep talking about all this data and not showing you anything. 2 more slides, and we're actually to what's beneath the hood. But I like to emphasize that in my regard as a system, when I introduce myself as a chief systems architect, it's not purely technology. I would say that 70% of my time is dealing with people and the teams, because they are the ones that actually create the value with the technology, and obviously all the code that we write that allows us to extract meaning from information. Sometimes, yes, it's automatically pushed out to people. It's very rare. I can tell you right now that there's only 2 things that occur in this world that we provide instantaneous notification of, and it's a pretty good thing. It's earthquakes and tsunamis. Those 2 things come to us in a highly structured format from the USGS and a couple of other sources like Forecast.io. But we parse that out and immediately have the latitude, longitude, epicenter, magnitude of an earthquake. We can calculate roughly the affected area if there's going to be a tsunami making landfall. Which, by the way, a few years ago in Thailand, there was a 42-minute heads up before that wave hit land. So anyone who had been subscribing to a service like this, which did not exist at the time, would have had possibly a life-saving alert. But those 2 things are really the only things that we have the confidence to push forward automatically. Everything else shows up in a queue that our real-time threat analysts that work in that watch center look at and say, yep, it's worthy, relevant, and then it pushes out. So we have this curation process. So we're almost to that curation process. We're almost to that point where we look at the data itself and how we use these tools. But first thought we should pause and look at some problems that everyone in this room at one point or another has probably asked themselves. Or if you're running a business or have responsibility for running a business, you've been forced to work through this. And what's the problem you're trying to solve? Whether that's a way to access a new segment of the market, or you have a particular failing, something you're not delivering on that you should. What is the problem to be solved? And then can the solution as you envision it, as you iterate through what is the problem, what is the fix, what is the problem, you continually iterate through that, can you fit that into a viable business model? Are you going to be able to make money on it? Obviously, you could just hire a lot more people to do certain kinds of work, but that's not necessarily cost effective. And when you're trying to monitor the amount and the variety of information that goes into threat reporting, you need some pretty sophisticated tools to scale. And so then what are the tools? And this is where I mentioned earlier, this is a discussion about general tool sets. I do a lot of woodworking and a bit of metalwork, and there's always a tool that's right for the job. And yes, you can drive a nail into a wall with a screwdriver if you try hard enough, but it's not the right tool. And so for us, Hadoop is a major part of that. And when I was first discussing with some of the members of Hortonworks, what would be a relevant topic to bring up. They thought that the manner in which we evolved as a company that looked at risk management and wanted to scale that in a new way, maybe the way we chose their tools would be worth talking about. So that's why we're talking more on a business track as opposed to technical today. So the bottom one is a bit of a departure from the top three, which are really highly business oriented. But this, how much is known, unknown but knowable, and absolutely unknowable. And I'm conflating a definition of a term here of model. We've got business models, and that's different from objects and data models, okay? So forgive me for interchanging those terms. But it's very important from a data modeling standpoint. You get an idea, and from a source collection standpoint, and this applies perfectly to transactional data if you're trying to monitor a point of sale system, or if you're trying to manage inventory and identify inventory loss, or identify sweet spots in terms of where you might need to procure, order new products to fill the shelves. There's a variety of business cases where you have some information available to you, and you know that. And then you have other things that if you could just get your hands on it, you know you could figure it out and it would be useful to you. And then there are things, especially in my world, that you can't possibly know. I had no idea that 3 guys were going to go in with bombs last night into an airport in Turkey. It's not knowable. But what you can do is begin to look at patterns and what we call indicators and precursors. So that gets into the predictive analytics. It's fascinating stuff, and we'll talk a little bit about that. So where we're at as a project, we've been 18 months in development now. And forgive me, I can't remember if in the first slide I mentioned the impetus for this entire product, which has been a significant build-out. Greenfield, there was nothing that existed. We spec'd out the entire data center. Everything was built from scratch. We didn't have legacy systems. We wish we would have had legacy data. There are companies we can buy some data from, but we quickly realized that we can harvest it all on our own, and so we started writing a bunch of Python scripts just to start scraping websites and scraping forums and blogs and parsing through emails from OSAC and the State Department when they talk about traveler advisories. That began to congeal into, we reached a point of critical mass where we knew we needed to systematize that, and that's really what the entire rest of this conversation is about. But the impetus was we were approached 2 years ago by the largest law firm in the world. They said, you guys have a very impressive track record in the defense and intelligence community, and we need help mitigating our own liability. When we send an attorney to Bogota, Colombia, how can we be sure, or at least mitigate the risk of them being subject to an express kidnapping and spending a very uncomfortable night in the trunk of a car? More than that, how can we ensure that the spouse doesn't come back and sue us because why did you send my wife or my husband to that place? You should have known better. That's liability that they wanted to mitigate. And so that was the impetus for me to say, I know we do this for DIA. We do this for a number of other government customers, and it's been most of my life in one form or another. But no one had ever really looked at the available technology. And the first thing that I realized was, well, it's not like it was an epiphany. We need to do this on scale across probably 98% of our information that's of value for threat detection, identification, alerting is unstructured, and it's not in English. And I further posited that a lot of it's probably not even in spoken words that's useful, knowing this from the fact that social media is as much emojis and symbols, and it's not like it's a dictionary. So I immediately started looking for things that we could do, natural language processing in foreign languages, and that's why I chose SAP HANA early on. But I knew that, again, we couldn't scale on that, largely from a cost standpoint. So we run SAP HANA as a 0.75 terabytes in-memory columnar data store. We do very rapid stream analytics on it. And again, we are systematically, from a business case, this makes a whole lot of sense. We're systematically implementing our own algorithms that will take the load off HANA, so as we scale, we can transition more and more into Hadoop. So that was the impetus. That's what got us in here, is to say, how can we build a system that addresses this for the private sector? Because we had a law firm that asked, how can you help us? So 5%, we knew kind of where bad places in the world were. 70%, we knew there was information there somewhere out there. We had to collect it. It was in websites that talk about where bad things happen. There's, in the United States, we are replete with things like citydata.org that allow you to take down to a street level or zip code level what crimes happen. Not so in Chad, Africa. Not so in Congo. So what can we do to fill in the gaps? Where, when we have sparse data sets, can we begin to either build the inference algorithms that help us connect dots, or at least help an analyst make an informed decision, build a good hypothesis. And so I've got these triangles, kind of like you are here markers down at the lower right-hand corner. This mouse is defying me. And it's kind of a grading as to where we're at. Like I mentioned earlier, we've got 39,000 sources. I got a screenshot here in a minute, so we'll know. We've got a whole lot of information that is allowing us to make some very good decisions about areas of towns and areas of countries that, and border areas that might present dangers. And I'm oversimplifying it, by the way, when I say areas of danger. We also look at business continuity, we look at coping mechanisms, we look at cultural parity assessments, how different is where you're going to where you're coming from. So I'm oversimplifying it when I just talk about threats at a physical level, but we'll get to that in a moment. So that 25% of unknowable, that is where we're at now. We're at the point where we're trying to say, based on information that's been collected, what can we predict? What's coming next? And so that's where the inference and predictive analytics come in. And so the deeper questions are, how do you even figure out what you know? How to get your arms wrapped around what you don't know? And what can you do to mitigate the risk of those things that you just know you cannot know with certainty? And that is the interpolate, infer, hypothesize. And this is really where we get to finally a technical piece of the conversation. And that is, we are one of the first users of NiFi. And while Anyara was a company that formed out of a few guys that left NSA, NiFi was in development there as a cooperative research and development process for about 8 years. And then it came into the open source community, and Anyara was formed, and Hortonworks bought them pretty quickly. Smart move. Because what NiFi is, a show of hands of people familiar with NiFi, it's obviously on the agenda. Data provenance, built a metadatabase around information. It allows some very, it's not complicated, but it can be complex in the way you piece them together. And I'm sure there are people in here that know more about NiFi than I do, but we recognized early on that we needed a means by which to take inventory of all the sources of information so that we can corroborate sources. We immediately put together SOPs that said our analysts can't say this is going on unless we have 5 sources that corroborate it. We also needed the ability to reach back in time and say, if you said this area of Chicago is a high threat area, why? Well, here's the 5 news articles that talk about people catching stray bullets. And we have, by the way, we have some very hardline requirements or criteria that say if the following conditions are met, any one of them, then it's a high threat or it's a moderate threat. So we have systematized some of that, and that's where a computer can definitely help us. But then there's other gray areas where you either don't have enough data or you've got part of one criteria, part of something else. I wouldn't send my mom there. You know, you're making some subjective calls. We have to be very careful with that, by the way, because we already get pushback from the mayor of a city that says, why are you saying this part of town is bad? I live near there. Well, again, it's data driven. You can be unhappy with yourself all you want. But we needed tools to allow us to take inventory of those feeds. So I won't spend a lot of time on this slide, but this is just a segment of our ontology that looks at threat modeling. And when I talk about threat parameterization, I don't know if you can read it, but inside those red areas that I just shaded, this, by the way, is from Protégé. It's a free open source tool used for modeling outputs in OWL, if you're familiar with it. So vulnerability and threat are in the upper right-hand corner, or that red block on the right. And you've got multiple arrows going back and forth. And what an ontology is it's a collection of entities and the relationships that define how they interact. And so if this were a live view of the ontology in Protégé, I mouse over one of those lines and you'd see it's a vulnerability is exploited by a threat. So this is what you're looking at is in essence a graph view of a triple store. So subject, predicate, object, which from a semantic processing standpoint you can see that is a very important piece of winnowing out meaning from unstructured text. I also put this slide up here just so you can have an idea of when we model data, and you do this in your jobs, and when you think about how to solve problems, you build your own lexicon, your own definitions. And for us, location, traveler, itinerary, threat parameterization for that matter, these were terms that we had to have very specific definitions for. And for the case of traveler safety and duty of care, a location, for instance, is a geographic area characterized by cultural norms, taboos, and chronic or emergent threats. It's a different kind of definition that most people would use. It's not just an XY, it's not just a latitude, longitude. It's a region that's characterized just like we as individuals are characterized by our own demographics, our own beliefs, our own ideologies. And on that note, since I reminded myself by saying ideologies, we're not just looking at people. Look at companies. Look at the risk profile of an agrochemical manufacturer like Monsanto. They're, and I'm not speaking out of school, they're more aware of this problem than I am, but, and if there was a rep from this company, they would agree. There are routinely protests by environmental protesters that look for where are they at. And so if the CEO of Monsanto is somewhere, that's where we focus the analytic lens on social media to say, is someone coordinating a protest or some sort of march there? So that's a kind of an abstract view of where you have ideological conflict that can manifest in unstructured data. So the ecosystem that we put together, and at one point that actually was an Excel sheet. I zoomed out and took a screenshot of, I think it was about 380 sources of information. We were very proud of having 380 something sources of information, and they all look like little dots. And now there's another slide coming up where you see our map view of the world. We built a system that allows us data curation tool set, that allows us to take a more complete inventory of this information that we need to determine where things are happening at in the world. But the theme here is that less is more. We have a deluge of information on the left, and NiFi. Anyone know why it's named NiFi? Got 5 or 6 people who, anyone? Niagara Files. Pretty clever. I got a hand to those guys. It's a deluge of information. And so what we wanted to have is a soda straw coming out of the other side with just something that's relevant to you based on who you are, where you're at, which, by the way, your location is an attribute of yourself. Anyway, where you're standing right now. So across the bottom, if you can't see it, example sources, RSS feeds, social media. So Twitter, when I say 40-something thousand sources, that's one source. Twitter is one source. In Hadoop, we perform sentiment analysis on tweets to the tune of 350,000 per minute. So pretty fast, pretty high throughput there. And just to be completely transparent on that, we're not doing that on a routine basis. We don't subscribe currently to the Firehose. Twitter shut us down. Their API sent us a calm message when we pulled 350,000 down in a minute, but we have the capacity to process the entire Firehose, because 350,000 times 60 times 24, it's over 500 million. So NiFi is what I refer to as our data manifold. That's where everything, like you have an 8-cylinder engine and going into one pipe for your exhaust, we have 48,000+ sources of information. We had about 150, 200 a day coming down into a single stream, not literally in terms of stream processing. Again, we're conflating terms. But we first run it through some very cursory parsing. I'll come back to this slide in a moment. I'm looking for one in particular. So this is NiFi. This is our dashboard, and inside each one of these boxes, it explodes into a larger breakout, in this case, our RSS parsers. So this is where we are looking for geocodable terms. Someone says Paris. Got to make sure you're not talking about Paris, Tennessee. You're saying Paris, France. Streets, intersections, names of entities. And in another slide, I have a screenshot of what we don't use for our in-stream processing, but it's a static where we built a form where we can just copy-paste news articles in any language in, and it uses HANA on the back end for entity extraction. So you can see where we're identifying which people, which organizations, which countries, what times, what's being discussed. And that's what we're trying to do on an automated level, so that when an analyst is saying, what the hell just happened in Turkey, he's got 4 things to look at instead of 40,000. And that's a good point to pause on this. So this, I've jumped into a search on Niger, the country. We have 139 sources or entries of our source database relevant to Niger out of 48,217. So this is curation. The analogy would be the Smithsonian has roughly, I think they have 90, I'll screw it up if I give you numbers, about 6% of their entire inventory of artifacts is on display at any given time. The vast majority is in a warehouse somewhere else, securely kept. And they choose, based on a given exhibit, based on a goal to communicate a message to the people going through the museum, which artifacts do you pull out to tell the right story. So that's what we're doing here. Out of 48,000 sources, 139 are relevant to Niger. And if you wanted to further sort and say, okay, what's going on with terrorism, we might have 7 sources that are relevant. So what's important really from a machine learning side, on the right-hand side of the screen, is we actually make a copy of everything that we scrape. So that's a locally persisted PDF, in this case of a website. We keep all that text. We like to build a corpus of text because there's machine learning algorithms like word vector that allow us to start looking at the semantic proximity. And this is where it gets really important when you're going to try and make sense of social media. There's a lot of, if you've actually heard any of the podcasts or CUBE interviews or stuff, I use this term more than I should. There's more smoke than fire in terms of social media analytics. 1, because very little of it's actually geocodable. But 2, we don't communicate in social media the way you do in a structured sentence that allows traditional NLP to function. So if you have, for instance, in San Salvador, El Salvador, a couple of warring gangs, which you have, and they do use social media, they don't do it with words that make sense to us, but they use emojis, emoticons, things that we can assign at a character level. Here's the UTF code for that symbol. And when we see that, we can look at what events correlate to it. It takes time to develop, but that's why we persist everything, and that's why we have built a data lake on Hadoop. So let me jump back into the part of the, so I was here, we're talking about less is more. The ecosystem that we have, obviously Hadoop plays a central role in the data lake itself. Just a few other examples, we use Hive to extract from, in the lower right-hand corner here, we have a PostGIS database. So when we want to query based on someone's location over here, this is a mobile user in the right, MongoDB is the back end for our mobile app, and that's a location-aware application, so every now and then they send a latitude and longitude. We're correlating those locations with high threat zones that have been drawn by a geospatial threat analyst. We're using HANA to run the complex geospatial queries to say, is this person near or contained in one of these areas that's high threat, which you saw in the earlier map, and I'll show you another example in a minute. And as we'll get to again in just a moment, that blown out view of our NiFi processors, we're parsing in the case that I was showing you, RSS feeds, looking for geocodable terms, looking for keywords that relate to the threat factors that we're tracking in terms of physical threats, health threats, environmental threats. And we might process it further for looking for specific entities or meaning or, again, sentiment, but we always persist it in HDFS. So everything's going into Hadoop. By the way, so 48,217, that's as of a couple days ago. We take a few out every now and then. It's another real benefit of NiFi. We know what's not being used, so when our analysts perform an assessment, which we've already assessed every country and every capital city, and we're working through all cities of 100,000 and more. We've already done all top 150 commerce areas of the world. But we can begin to identify what sources really aren't useful so we can get rid of them. So over on the left, you see factors. This goes back to the data modeling and that maze of the ontological view that we showed earlier. Decomposing physical, environmental, and health threats into different factors, like environmental is obviously earthquakes and things because you're on planet Earth. Health, it's not simply endemic diseases, is it safe to drink the water, but also the coping mechanisms that offset that. Another corollary would be you've got crime, but you've got a robust police force, or do you have a corrupt police force? So corruption indices are a big part of what we look at. This is just a view of this is a major piece of the human level of effort. If this could scroll down in the static view, you'd see that we've got about 780 ongoing threat assessments. Again, this is where the humans are using this curated data set. Because obviously they can't go out and just Google every time they want to know something about Turkey or France or Nepal. So very robust QC process. There's actually 6 checkpoints along the way before it actually is approved for artwork. That's really beyond the scope of this conversation. But so based on that distillation of what's going on in Niger, as an example, we build a plot, very simplistic, but what are the top threats? For contrast, in a benign area like Finland, immediately we can see that there's not as much going on. But in each case, if you were to click on source, sorry, I don't know what my smartwatch was doing there, talking to me. Maybe it'll do the presentation for me. But the do's and don'ts, infographics, this is actually the back end that feeds information to the mobile device. So those earlier screenshots you saw are being fed by this system here, which again we call the source and assessment tracking system. So back to Niger, we see high threats. We already looked at this. We talked about where we persist the natural language that is processed in stream form as it comes through. In this case, it's just a news article that we scraped. Many other times it's an RSS update. And then from that, we're able to compile a salient and up-to-date threat report, what's actually been happening recently. And so in a consumer version, which is what you'd see on a mobile device, you have the threat report for Niger. And if there, again, less is more. If there isn't something significant, we don't talk about it. But on the right-hand side, you've got the analyst annotations. And I want to highlight, to again, kind of underscore this threat parameterization bit, female versus male threat scores, significantly different in Niger. That's based on both incident rate, what actually is reported, but also based on a cultural assessment. And Australia is another example where I often bring up culture affects the veracity of information. So this is something, so in 50 seconds, outstanding, thank you. Good sign. So it's a process of, again, culling and finding out what's relevant, but factoring into it, subjectively sometimes, how accurate is this information we're getting. So that's really it. The last slides I had were examples of the entity extraction. I don't know if there's any time for questions, but that really is the totality of the presentation. Sir? We're very familiar, yeah.
Have you contributed, say, maybe older information? Because GDEL is more of a long-term archive for like trending and
yeah. The closest thing we've done is with OSAC, which is the U.S. State Department, providing them some information back because we do parse everything OSAC sends. We've looked at GDELT, and we've actually been able to find, we haven't been able to find anything unique or new within that because we get it from so many other sources. But you bring up a point in terms of like system optimization that I forgot to mention earlier. With this system, we've actually seen a 700% uptick in our efficiency of producing geospatial threat analyses. So the rate at which our analysts can cull through and figure out what's going on in a given region, which, by the way, that's a polygon that says who's in this area, who needs to get a threat alert, 700% uptick based on how we cull this data.
And have you looked at doing any of the geospatial analytics inside of Hadoop or NiFi versus look like you're calling out to Mongo for your location and proximity?
Well, MongoDB is the backend for the web application and the mobile app. So yes, we pull all that down. We built a REST API. We also use SAP HANA Smart Data Access. So anytime there's a change in location or a change in one of these high threat areas, we check who's in or near that. But MongoDB is the backend that we needed for the mobile and the web so we can geographically distribute and shard out all that data around the world. Because sometimes we have to put that MongoDB backend needs to be in Europe because the EU citizens can't have their data somewhere else. Yes? All right. I can hang out back here if anyone else has other questions. Thank you very much. Appreciate your attention.